Hi, my name is Sarah, and on behalf of the University of Florida, my partner Tyler and I invite you to take a journey with us down the tortoise hole to discuss techniques for estimating gopher tortoise abundance. Assessments regarding the size of gopher tortoise populations have been difficult to perform due in part to the fossorial nature of the species. Populations also have low numbers, occur in low densities, and are relatively isolated from each other. These assessments have been further hindered by a lack of standardization in survey methods. Today, we'll be evaluating 3 common techniques to estimate gopher tortoise abundance based on the following criteria: effectiveness, practicality, and time efficiency. Capture, mark, recapture is a 3-step process that requires researchers to capture and mark a sample of the population, then resample the population, and perform calculations based on the number of marked individuals that were recaptured. For long-term studies, turtles are often marked using an electric drill or triangular file to create permanent visible notches around the top of the shell, called the carapace. Short-term studies often apply acrylic paint to the carapace to make temporary yet noticeable marks. Capture, mark, recapture is often hailed as the gold standard for estimating wildlife abundance. However, it is the most labor-intensive method and requires that the animals be handled by humans. Studies have shown that direct contact results in an observed difference in gopher tortoise behavior immediately after handling.
If one wishes to avoid contact with gopher tortoises, then complete burrow counts are an alternative solution. This method is performed by a large group of observers walking side by side and systematically sweeping across a site while mapping burrows with GPS. Afterwards, occupancy is either inferred by recent signs or confirmed with camera scoping. If burrow activity is based on recent signs, then population estimates are obtained by applying a standard correction factor, which describes the predicted relationship between the number of burrows and the number of tortoises. However, if burrow activity is based on camera scoping, then there is no need for correction factors because real occupancy can be observed. Burrow counts work well for low populations of gopher tortoises found at small survey sites, which can be more realistic for isolated patches of habitat. The complete detection of burrows provides an exact number of burrows for which population estimates can be made, but the assumption of complete detection is rarely achieved, and the method does not offer realistic opportunities for repetition. It is also the most labor-intensive process. The third method is line transect distance sampling. This method is achieved by detecting tortoises or burrows along randomly distributed transects and then separately determining occupancy. Imperfect detection is accounted for by modeling the decrease in detection probability as distance from the transect increases. To extrapolate population size, either a standard correction factor can be applied to the burrow count, or camera scoping can provide occupancy data. One of the strongest advantages to this method is that not all tortoises or burrows have to be detected, only the distance at which they're observed from the transect. Unlike the burrow count method, distance sampling provides statistically rigorous estimates which incorporate detection probability and confidence intervals. It works especially well for large populations and large areas, but becomes less effective at small sites with low sample sizes. Choosing to observe occupancy of the burrows with camera scoping will also make the process longer to perform. When considering the criteria of effectiveness, practicality, and time efficiency, we recommend line transect distance sampling of burrows along with camera scope observations to determine occupancy. Since burrows are detected rather than tortoises, the distances from transects can easily be recorded without incurring an observer effect. The randomly distributed placement of transects allows for efficient surveying in large areas without requiring complete detection. Limitations of distance sampling for small populations or areas can be overcome by repeating the sampling until a sufficient sample size is obtained. Choosing to detect burrows will also significantly increase the sample size because gopher tortoises utilize multiple burrows. When comparing the use of correction factors or camera scoping, we believe that camera scoping is the better option despite sacrifices in time and labor. Studies have shown that the standard correction factors used to estimate population size varied significantly by the observer, seasonality, and site-specific conditions. Burrow scoping is much less subjective, but some burrows will have obstructions that prevent the use of cameras. Following our recommendation will allow for the use of distance sampling for both large and small populations and, more importantly, obtain more accurate and robust population estimates to assess population trends.
We would like to acknowledge our references and thank you, our viewers, for your time and attention. Please feel free to leave any questions or suggestions down in the comments below. We sincerely appreciate your feedback.